Bismillahirrahmanirrahim. Welcome to the solution mock 1. So first let's analyze the topology. So we have three VLANs, VLAN 10, okay, then VLAN 20 and VLAN 30 and VLAN 99. VLAN 99 is for the management purpose. And the VTP details are configured. And this is the switch 1 and switch 2 and switch 3 IP configurations. So these are the configurations for the HSRP. This is router R1, this is router R2. Okay, so the default gateway is 10.1. Okay, and 10.2 is the IP for the VLAN 10 in the R1, and the 10.3 is the IP for the VLAN 10 in the R2, and the default gateway is 10.1. So if you go and check, it would be 10.1. For the VLAN 20, the IP is 20.2 in the R1 and 20.3 in the R2, and so on for the VLAN 30 and VLAN 99. For all the VLANs, the default gateway is 99. You can check this. R1 should be the active router for VLAN 10 and 20, and R3 should be the active router for the VLAN 30 and 99. What it means is, in the HSRP configuration, R1 is a active router for the VLAN 10 and 20. So all the VLAN 20 and 10, VLAN 10 and 20 traffic go through the R1 to this border router R3. And VLAN 30 and VLAN 99 traffic, they go to R2, and from R2 it goes to the border router. So for the VLAN 10 and 20, this is active, and for the VLAN 30 and 99, it is active. So how you can verify this? If you go here, show run command. So you can see for the VLAN 10 and VLAN 20, the priority value is high. The default priority is 100, but here, okay, the priority given for the VLAN 10 and 20 is 120. That means for the VLAN 10 and 20, the R1 is the active router. And now you can see for the VLAN 30 and VLAN 99, the priority value has been reduced. Instead of increasing the priority in the other router, the priority has been reduced from 100 to 80. So for VLAN 30 and VLAN 99, the R1 will not be the active router. Why? The priority has been reduced to 80 and the R2 priority is 100. So for the VLAN 30 and VLAN 99, R2 is the active router. And for the VLAN 10 and the VLAN 20, R1 is the active router. Okay. So these clarifications I want to give. And this is the ISP router, and this is the server 0 which is connected to the ISP, and server 1 is connected to the organization network. This is the organization inside network. Okay, so this server 1 is part of the organization network, inside network. Okay, now let's go to the question number 1. Network address or port address translation is mandatory at R3. So they are asking us to configure the port address translation at the R3 router. Okay, so the R3 router is connected to the ISP. They are asking us to use only one public IP. So this is the public IP 200.200.200.3. Okay, they are asking us to create a pool, and in that pool the starting and the ending is the same. Okay, so only one public IP. All LAN and VLAN IP connected to the LAN should be translated when they communicate with the ISP or the PC connected to the ISP. So that is, they are asking us to create the patch. Okay, so that is the first step. So we'll go to this R3, enable config T. Okay, so now what are the different interfaces are available? So we have these interfaces in R3. Gig 0/0 connecting to server 1, AC 0/0/1 connecting to the R2 HSRP router, and AC 0/0/0 connecting R3 with the R1 HSRP router, and AC 0/1/1 is connecting with the server 0. I mean, sorry, it is connecting to the ISP. This is ISP. Okay. So let's proceed. Okay. So now what we have to do is we have to configure the access list for the PAT. Okay. So these are the networks, right? So in this network, okay, so we have like 4 VLANs. Okay, so among the 4 VLANs, let us assume the VLAN 30, VLAN 20, and VLAN 10. Obviously, they need PAT translation, port address translation, NAT, because they might the systems in these VLANs, they might access the servers or services outside. And VLAN 99 is for administrative purpose or management purpose. So I don't want to include this particular VLAN in the uh, access control list. Okay. So create a access control list here. So please read the question. Is there they are asking us to create any name? Okay. Okay. You have to follow all these things. Is mandated R3 where the campus has access to ISP. Use IP address as a start and end of the pool range and call the pool range. Okay, and all LAN and connected to this should be translated when they communicate with the PC connected to this. Okay, so they are not asking us to create any uh, name. Okay, so we create. So this is the first network, 10.0. So you can see here 10 network we have, 20 network, and 30 network, and 99 network. This is the IP address. Okay, so from this IP, I hope you know how to find the network address. So 192.168.10.0 is the network address, 20.0, and so on. And the wildcard mask, this is slash 24. That means 255, 255, 255.0. And the wildcard mask is 0.0.0.0.255. So this is the wildcard mask because this one is slash 24. Okay, then we go to the second statement in the access list. We add the second network also, and we add the third network, that is 30 network, because whichever network needs the NAT translation, so they have to be added in the access list. Okay, so this access list is created for the port address translation. So after the first step is creating the access list. Then after creating the access list, we are going to create a pool. The name of the pool is NAT pool. This is the name of the pool. So IP NAT pool, we are creating the pool, and the name of the pool is NAT pool. And this is the public IP which has been mentioned in the question. So this is the starting, and this is the ending, because only one public IP is given. So the starting and ending is same. Suppose in exam, let's say they give like 200, 200, 200 or 3, comma 200, 200 dot 5. So the pool should have a range of IP addresses from 3 until 5. In that situation, they would have given the subnet mask or wildcard mask details. Then you have to enter it here. Since there is no such things are given, okay, we put like only one IP is needed here. So we put the wild net mask as 255, 255, 255, 255. So it means that only one IP is used in the pool, and all the octets should be matching exactly this. So we use 255, 255, 255, 255. Suppose again I repeat, if there is a set of IP addresses with subnet mask, then you have to change here as we did in the project. So I create the pool here. The pool has been created. Okay, then let's say we have created the access list, and then we have created the pool, and the third statement is mapping the pool with the access list. So IP NAT inside source is list 1. This is the access list what we have created, and the pool name is NAT underscore pool. Okay, so overload, because if you forget this, it becomes dynamic NAT, which has some shortcomings, like since there is only one IP, public IP, only one system at a time can access the public network, and same time other systems they have to keep waiting. So to overcome this drawback, okay, we add the overload. When you add the overload, it becomes PAT, port address translation. So now we add this statement. So this statement is connecting the access list 1 with the pool. Okay, so it's done. So next what we are going to do is, like, we have to identify the interfaces. Just go here. We have 4 interfaces connected to the R3 router, and we have to identify which is IP NAT outside and which is IP NAT inside. So obviously, please try to understand. This is a inside network, completely inside network. Okay, so this is inside network, and this is also inside network. Okay, so only this one is outside network. So we have 4 interfaces. You can see here we have 4 interfaces. So all the interfaces are IP NAT inside except AC 0/1/0. This is okay, outside, whereas all the other interfaces are inside. So this is the next step what you have to do here. Okay, so interface, okay, gig 0/0 IP NAT inside interface serial 0/0/1 IP NAT inside interface AC 0/0/0 IP NAT inside interface serial 0/1/1 IP NAT outside. Okay, so even in the exam, please students, you have to understand which is inside the part of the organization network, all the interfaces that connect the inside network, okay, to the border router is IP NAT inside. So the interface that connects a border router with the ISP is IP NAT outside. Okay, so let's go here. So if you see this too much crowded, just go to preferences. Okay, just remove this stuff. Okay, then close this, close this. Then just options, preferences, show port labels when mouse over in. Okay, so just let me take the mouse here so you can see the interface name correctly. So this would be a better approach. You will not get confused. Okay. So we have finished the question number 1. Okay, so the port address translation is perfectly done. Okay, and okay, we can test this thing. Let's say, so we have this server. This is the IP of the server 8.8.8. Okay, just go to PCA and then open the browser. Okay, then let's say 8.8.8.8. So it's working perfectly. Okay, so just go here and show IP NAT translation. So you can see this command. Okay, so this is the inside network, inside local. The private IP of the system, okay, in the inside network is inside local, and the public IP what we assign to these systems through the port address translation is called inside global. See, it is mapped correctly, and this port number has been assigned to this system, and this is the target system. So that target system is outside global as well as outside local. Okay, so the first question is working perfectly. Okay, now let's move on to the second question. Block the VLAN 10 from accessing VLAN 30. Allow access to all other networks. Use access list number 110. So access list 110 means it is an extended access list. You have to understand it's an extended access list. So the question is VLAN 10 traffic to VLAN 30 is not allowed, but the VLAN 10 can access VLAN 20, VLAN or any other VLAN, or as well as it can access the ISP, as well as it can access the server 0, allowed, but only traffic to the VLAN 30 is not allowed. Okay, so where we have to do this configuration. Okay, so the question says block the traffic from VLAN 10 and use the extended access list. Okay, 110 is the extended access list. So you can see here for VLAN 10, which router is active? R1. So you have to do the configuration in R1. You might ask one question. Shall I repeat in R2? No, you can repeat, but no need. Because R1 is the active router. In case R1 is not working, then the traffic will, the VLAN 10, VLAN for the VLAN 10 and VLAN 20, the R2 will become the active router. But we should, I think we shouldn't think too much. at the organization level in real-time scenarios. This is just examination. The scenario is given to us. They are telling, okay, R1 is active for the VLAN 10 and VLAN 20. So let's just do the configuration in the R1. No need to go to the R2. It is optional. Let me make it very clear. It's optional. Only when the R1 there is a hardware failure, the R1 is not working. In that situations, you might need the R2. You need the same configuration in the R2. But as far as the examination is concerned, okay, at this level, okay, let's follow this. R1 should be the active router for the VLAN 10 and 20. So I am going to do in the R1. Okay, so it is extended access list. So we have to block the VLAN 10 traffic. Okay. So if you take this R1, this is R1. Okay, if you take the R1, so you have many sub interfaces. VLAN 10, VLAN 20, VLAN 30, and VLAN 99. So we have like we have like uh, this interface is what gig 0/1. So gig 0/1 dot 10. Okay, so this one gig 0/1 dot 20 and gig 0/10 dot /1 dot 30 and gig 0/1 dot 99. So so please try to understand for the R1. Okay, so for the R1, this is for the R1, and same thing for the R2 also. So you have the so I'm sorry, it's disturbing me. So let it be. Just try to understand in R1 and R2, you have these sub interfaces. So now the question number 2 says, from VLAN 10, the traffic should not go to VLAN 30. Okay, so from VLAN 10, the traffic should not go to VLAN 30. Okay, so this is R1. So I don't know how to copy this stuff. Bismillah. Okay, so we have like this. So from VLAN, okay, so it's like this. So a traffic, okay, is going to the VLAN 10. From the VLAN 10, the traffic is going to the R1 router. You can ask why R1, because for the VLAN 10, R1 is the active router. So the traffic is going here. And from here, the traffic, what it does, okay, it will it will come out through the VLAN 30 like this. So from the VLAN 10, okay, again I repeat, from the VLAN 10, okay, the traffic enters the sub interface, and then, okay, through the router it will come out through the VLAN 0/1.30, this sub interface which belongs to VLAN 30. So now we don't want the traffic from VLAN 10 to go to the VLAN 30. So what we are going to do is we are going to create an access list, and we are going to apply this access list to this interface, to this interface. Why this interface? Because the traffic is entering through this interface only from the VLAN 10. So for this interface, the traffic is incoming. Okay, and for the VLAN 30, the traffic is outgoing. Is this point clear? Okay, so we are going to, since this is extended access list, so please configure and apply the extended access list very close to the source. So this is the source here. The source is here. So I am going to apply this access list very near to the source, that is gig 0/1.10, so that the traffic from the VLAN 10, okay, if it is going, okay, what happens? The traffic is, okay, the traffic is blocked here. Why this? Because this interface is very near to the near the VLAN 10, very near to the VLAN 10. Okay, so let's do this. So I go to the R1. You can again see VLAN 10. R1 is the active router. Enable config T. Okay, just read the question again. Block VLAN 10 from accessing VLAN 30. Allow access to all other network. Use access list number 110. So this is the access list. Okay, so let me make it slightly bigger. So access list 110, deny the source. Okay, this is a source, the 10 network 10.0, the wildcard mask. This is the source, and this is the destination. So we are denying IP traffic, and this is the source, and this is the destination. So, and we are allowing everything else. Access list 110 permit IP any. We should allow access to all other networks. So we are allowing access list 110 permit IP any. If you forget to put this, then the traffics might be blocked. Understand the default one is deny. If any rule is not matching, then that traffic would be denied. So that's why I put it here. Can I put this here in the first? No. When you put this in the first statement, what happens? Any traffic from the VLAN 10 even to the VLAN 30 is allowed as per this statement. So that's why you have to put, any deny statement explicit, deny or permit. Explicit deny or permit should be in the beginning, and all permit all statement or deny all statement should be at the end. Okay, so let's do this stuff in the R1 router. So I go to the R1 and configure this, and then access list IP any. So some students they do this, and they complain that teacher, the access list is not working. So I go here. Okay, this is VLAN. What's the question here? I forgot the question. So the traffic should not be allowed from VLAN 10 to VLAN 30. Okay, so I go to VLAN 10. Okay, and so I go ping 192.168.30.130. I'm not able to ping the, yeah, it's pinging. So we have configured the access list, but still we are not able to, well, sorry, still we are able to ping. Why? Because we did not apply the access list yet to a specific interface. So that's what I explained to you. So you have to apply this access list what we created 110 to the this interface gig 0/1.1 interface to the incoming traffic. So to the incoming traffic you have to apply. So we'll go to that now. So we'll go to interface, this interface in the R1, and then let's say we go to this incoming. Okay, then let's exit. So I and write the configurations. Okay, then let's repeat this again. Now you can see the access list is working perfectly. So the traffic from VLAN 10 is not allowed to the VLAN 30. However, if you want to access the VLAN 20, it should be pinging. It should be pinging. Yes, it's pinging. However, you can see it's not pinging to VLAN 30. Okay, so we have finished the second question also. So, you know why I did in R1? Because R1 should be the active router for VLAN 10 and 20. Maybe if this information is not given in your exam, also you have to be very careful. Just go to run command and check for that particular VLAN, which is the active router using by checking the priority number. If the priority number is high, see here it's 120. If you go here, enable show run. So there is no priority number given. That means the default one is 100. So here this R1 is 120 and here R2 is 100. So obviously R1 is the active router for the VLAN 10 and 20. Okay. However, for the 30 and 99, it has low priority. R2 has high priority. So R2 is the default or active router for the 30 and 99. So we are finishing the second question also, alhamdulillah. So we are moving on to the question number 3. Block VLAN 20 from having access to the internet server, but allow it to access the ISP router and other networks. Used extended access list to implement this. Okay, so block VLAN 20 from having access to the internet server. Okay, but allow it to access ISP router and other networks. It's very easy. So this question says the VLAN 20, this system traffic will start from here, then it will go here, then it will go to R1. Why? Because it is in VLAN 20. For VLAN 20, R1 is active router. Then it goes to R3 and then it goes to ISP and it will access this server. And the server is 8888. Okay, let's check here. If you go here and the browser, So 8.8.8.8, we are able to access the server. So the question number 3 says the VLAN 20 should not be allowed to access the server 0. So you know what is the IP address of the server. Okay, 8.8.8. So this is the IP of the server 0 and this is the subnet mask. So VLAN 20 should not be allowed to access this server. But the VLAN 20 can access any other system. Okay. So where you will apply the access list? This is extended access list. So which is the source? VLAN 20 is the source. This is the source. Now which interface is near to the VLAN 20? R1. Okay, so the device near the gateway is R1. The traffic will enter the R1 and from there it will go. So here you have like many interfaces. So now we are talking about the VLAN 20, right? So now, okay, so this will be removed. So we are talking about the VLAN 20. So the traffic basically will enter the VLAN 20 interface and then it goes to the border router and then ISP. So the traffic is entering through this R1. So you have to create an access list and apply the access list and block the traffic here in this interface. So this is what we are going to do. So that which traffic should be blocked? The traffic which is going to the 8, the traffic from the VLAN 20 which is going to the host 8.8.8, that traffic is blocked and all the other traffics are allowed. If the source network is 20 and the destination system host means a specific computer, okay, 8.8.8. Okay, so we are going to do in the R1. You know why R1 I have selected this. So I go to R1 here. Okay. So access list, please be careful with the access list number. The access list number should not be different. Okay, so access list number is this 120. The source IP, the network address, this is the source network address, and this is the destination host. Okay, so we are denying that traffic to the server 0, but this one is must, otherwise all the traffic will be blocked because by default deny is the last statement implicitly inserted. To override that you should put permit. If you don't put the permit, that means all the other traffic would also be denied. Okay, so we have created the access list and then I said like we have to apply this access list to the gig 0/1.20 sub interface. Okay, so like let's say you might get the doubt, why should be here? Can I do it here? Can I do it here? Of course you can block the traffic here, but why you move far away from the source? Keep it near the source because it is extended access list. Are you getting my point? So if you are putting in this interface incoming, if it is here it is outgoing. If you ask me, can I do it here? Okay, do it. No, but the question is, listen, you should be near to the source as much as possible for the extended access list. Okay, so we are going to apply this to the this interface. Then let's say applying to the interface here. Okay, exit. So now let's check this how it's working. Let me go here. You remember earlier I was able to access the 8.8.8. So you can see it's not accessing the service web service in the server 0, as well as request time. So the access list is working perfectly, and so alhamdulillah we solved the question number 3 also. Allow the internet server to access the local server 1, question number 4, for email and web traffic only. Block access to all other services on the server 1. Allow internet server to access all other parts of the network. Use named access list to implement this. So what it says is this, like this server, if it is connecting to the server 1, if it wants to access the server 1, okay, then allow the email traffic or the web traffic. Don't allow any other traffic like ICMP or any other traffic is not allowed. At the same time, the server 0 should be allowed to access any other system in the network anywhere. So the question is very simple. This is the source, this is the destination. Now, this is, sorry, not only this destination, everything is a destination. Okay, so this is the source. Now, this system, the source system, should be, when it is accessing this specific system, only email or web is allowed. So, use named access list SRV. Okay, so you have to use the name. Then it is asking us to allow email traffic and web traffic. Obviously, it is extended access list. If it is extended access list, please keep the access list near the source. So the near the source, this is the router. So in this router, this interface gig 0/0 is the nearest interface. So I'm going to create the access list in the ISP and put the and apply that to the gig 0/0 interface to the incoming traffic. So if you're asking, can I apply here? Yes. So let's create the access list here. So here, okay, so we are creating access list with this specific name. So be careful even in the exam, because they would give marks for this name and all. So once you create the access list using name, so only permit or deny, you should start from permit or deny, because you enter the interface of the access list, and no need to like put the IP access list, the number and all. So this mistake you are prone to commit, so be careful. So okay, let's see, we have to allow the email traffic, so SMTP, POP3, IMAP, okay, whatever. If you want to add like SMTPS, I mean like secured SMTP, secured POP3, but no need. Okay, keep it simple. Okay, so these are the email protocols. So I permit them. You can see the statement. The source is this. I use the host statement because the source is a specific system. We are not talking about a specific source network. We are talking about the specific host system. And the target also is not a network. The target also is a specific host. Okay, so host, this is the specific host. And this specific host, be careful. In the exam, they might sometimes give you static NAT. If they are giving static NAT, then the public IP of the static NAT you have to use in the exam. Here, there is no static NAT for the server in the inside network, so I use a private. Okay, so this is the email protocol. Then I go to I permit the POP3. So POP3 is also part of the email traffic. And then I allow the IMAP. Okay, this is also part of the email. What's the permit TCP? Okay. SMTP, POP3, FTP, SMTP. That's enough. Okay, guys, this is enough for the email. Okay, so SMTP I added and POP3 I added. So this is enough for the email traffic. Suppose you want for IMAP, you have to find the port number and then you have to allow. I don't want you to go that much very deep. Just enough POP3 and SMTP is enough. Okay. So now we have to. Okay. So this one I remove this. Okay. Then we go to the web traffic. And then let's say we want to allow the secured web traffic, HTTPS. Okay, so any other traffic, deny IP host, deny IP host. Okay, um, so this server IP, this 100.2. So the document in which I send you, there might be a mistake. I put some 200 something stuff here. So please remove that. So this is the correct. So now we allow these traffic to this from the 8.8.8 to 172.1600.2. From here to here, we allow the email and we allow the web. So once we did this, we have to deny all the other traffic, right? So how you do this? Using this statement. So the document which I sent to you, this statement there is a mistake. I put some other IP here. Okay, be careful, remove that. So what I'm trying to say is this. See, this IP is not correct. Remove it. Put this 172.16.100.2. Okay, so this. So we deny all the other traffic from the from the server 0 to server 1. Okay, so this is specific, like between the server 0 and server 1. We will allow email and web, and we deny all the other traffic. And also through this interface, okay, other traffics would be flowing, like to the ISP. That should be allowed. So we put permit IP any. Okay, so permit IP any. So see the distinction between this statement and this statement. This statement is explicitly denying any other traffic other than the email and web between the 8.8.8 system, that is server 0, and 172.16.100.2, that is the server 1 system in the inside network. Okay, and then let's say from here, this system, through the ISP, other traffic will be going to here R3, and somewhere the other traffics will be going. So that traffic should be allowed. Am I clear? So that's why I put this permit IP any. So exit, okay, and right. So now we will go to the server and examine whether this particular access list is working or not. So I go to like 172. Okay, then so it's 72.16 16.100.2. So we are able to access. Even let's say you try to examine the web traffic, you should be able to I mean email traffic also, it is allowed. You can access. And also let's say https://172.16.100.2. See, HTTPS traffic also allowed. However, if you try to ping 172.16.100.2, oh, it's, yeah. You know why we are able to ping? Because we have created the access list, but we did not apply. This mistake even you can commit in your exam. So unless or until you apply, it's not going to it take effect. So like uh, it's pinging now. So I go to this interface. I told you why I go to this interface, because this interface is near the source, and this is extended access list. So we have to apply to the interface near the source. It is recommended, best practice, but in some situations, in different some other different situations, it might vary, but mostly this is the practice as far as the extended access list is concerned. Okay, go to this interface. Okay, then we go to this apply this to the incoming traffic. Okay, exit. Okay, exit and end. Right. Okay, then we go and check again. One 72.16 0 sorry 100.2. We are able to access, and HTTPS also you should be able to access. And if you test the email also, you can access. However, this ICMP should not work. Yes, it is not working. Perfect. So Alhamdulillah, we were able to complete the question number 4 also successfully. And then we come to the question number 5. So question number 5 is design an access list that denies all FTP traffic from VLAN 30 to server 1. Okay, so this is VLAN 30. So from VLAN 30, okay, so the traffic, now tell me, from VLAN 30, the traffic would go via R1 or R2? Obviously through the R2, because there's a mistake here. R2 should be the active router for the VLAN 30 and 99. Okay, here there is a mistake. Okay, so the traffic go through the R2 to the server 1. So from the VLAN 30 network, okay, the traffic to the server 1 is allowed. Okay, let them access the web server, email server, no problem. But no FTP traffic is allowed. The FTP traffic should not be allowed. So you have to create the access list in the R2, not in the R1. Why? Because for VLAN 30, the VLAN 30 is the source for which you are going to configure the extended access list. So, okay, the traffic is going to go through the R2. So the nearest router is R2 and the nearest interface is this gig 0/1. So you have to create the access list here and apply the access list here. Okay, so enable config T. Okay, so let me go here. So services, FTP is on. Okay, you can see the username is Cisco. So from here, before I configure the access list from the VLAN 30, okay, so FTP 172.16.100. I think to write Cisco. So we are connected to the FTP. So FTP is a protocol which is used to transfer the files between the client and the server. Okay. So now we are successfully connected to the FTP and I have disconnected. So from VLAN 30, there should not be any FTP connection to the server 1. So we go here. Okay, so in the server 1, okay, you have to, the traffic is going to go through the 1.30 interface. It's going to go through this interface. So you have to create the access list and block the traffic, FTP traffic in this interface. Okay, so let's go to here. Okay, so access list 130, they're asking us to create the access list. Design an access list that denies FTP traffic from VLAN 30 that is destined for server 1 but permits all other traffic. So they did not give any name. They did not give any number, right? So then you can choose your own number. In case they are asking you to use some specific number, then you have to use that number. So anything between 100 to 199 you can use for extended access list. So access list 130 deny. The TCP FTP uses the TCP, the transport layer. The source network is 192.168.30.0 and the wildcard mask is 0.0.0.250 because it is /24 network. And the target is not a network. The target is a specific system. So we use the keyword host. If it is a network, target is a network, then you have to use the network address as well as the wildcard mask. Then equal FTP, FTP request and FTP data. Okay, so even you can use equal 20 equal 21 also 21 and 20 and 21 also you can use. So I am using this stuff here. Okay, then even 20 is so equal FTP data is not that. So I put here like this. So 21, and I put 20. So this is also perfectly all right for the FTP traffic. So we are blocking the FTP. After blocking that FTP traffic, you should um, allow the other traffic using this statement IP any. Then you should apply this to this specific interface to the incoming traffic. So incoming traffic, right? So and right. So now you can check whether it's working perfectly or not. So go to here, what's that command prompt. So statement is already there, FTP. So you see now the FTP traffic is not working. Okay, so FTP traffic is not working from the VLAN 30. Okay, so you know why we go very near to the source, because let's say from VLAN 20 as well as in from VLAN 10 the FTP traffic might go to the server 1, and this access list is not going to affect any of them because we have kept the access list as close as to the source. Okay, so um, so this is the fifth one we have successfully finished. So then the last question is this: VLAN 30 staff should be the only staff members who can access the network devices through the telnet uses a standard access list number 13 will apply this access list to the router VTY lines. Okay, so the only VLAN 30 should be allowed. Uh, so let me close all these things. So the last question is this. Let's say let's go to this R3. Okay, so let's say that VLAN 10, VLAN 20, and VLAN 30 are there. Okay, so we have to allow only VLAN 30 system to access the any router at R1, R2, or R3 through the VTY. Okay, so in the VTY, you know, there are two connections are possible. One is telnet, another is SSH. Okay, so telnet is not secured, SSH is secure. Okay, so config T. Okay, telnet. Okay, so what's the IP of this system? Just move the mouse here. So just take the SE 0/0/0/1, and the IP address is 10.10.10.2. So go to this telnet 10.10.10.2. Let me check. The last question, this question I will put as a separate video and send to you. Okay, because by default the telnet is not connecting. But however, just you have to let me clarify that in the routers as well as in the switches, you can create access list, and this access list is a standard access list. Okay, and then you just permit this network, 30 network. And if you're not including any other network, it means by default they are denied. And then you go to the line VTY 015 and you just block the traffic. Okay, thank you very much.